Hello guys, so we'll solve this problem today where we have a concrete wall. It has a surface area of 20 meters square and thickness of 0.3 meters, and it separates a conditioned room air from ambient air. So temperature of the inner surface of the wall is maintained at 25 degrees Celsius and thermal conductivity of the concrete is 1 watt per meter Kelvin. So we have to determine the heat loss through the wall for outer surface temperature ranging from minus 15 degrees Celsius to 38 degrees Celsius. And for the second part of this problem, we have to plot the heat loss as a function of the outer surface temperature. So for this also we have varying thermal conductivities. We have to take this 1 watt per meter Kelvin and 0.75 and 1.25 watt per meter Kelvin thermal conductivities also. So let us first write down what are the known factors in this problem. So we know the temperature inside the room, we know the cross sectional area, and thickness of the wall, and we know thermal conductivities. Okay, and we are going to find heat loss or heat rate Q for varying ranges of temperatures. So if we draw a schematic for this, so we have this wall for which thickness is T equal to 0.3 meter. This is the thickness. Let us consider this as outside. So T outside is varying from minus 15 degrees Celsius to 38 degrees Celsius, and let us say this side is inside, and inside temperature T in is 25 degrees Celsius, and if we convert it into kelvins, it comes out to be 25 plus 273, which is 298 Kelvin. And similarly for outside temperature, our range is 258 kelvins to 311 Kelvin. Now also we know the cross sectional area for this wall is 20 meters square and thermal conductivity K as 1 watt per meter Kelvin. So what are the assumptions for this problem? So assumptions are, first, it is a steady state heat transfer, meaning heat transfer is not changing with respect to time. Second is it is one dimensional heat conduction through the wall. So this is the wall, and we are assuming that heat conduction is either in the right direction or the left direction, only one dimensional. It is not going into positive or negative y or z axis. And third assumption is throughout the range of temperatures we have constant thermal conductivities. So we can we will use here Fourier's law, which is heat loss or heat transfer can be given as minus thermal conductivity K multiplied by cross sectional area A into dt by dx, which can also be written as Q equal to minus thermal conductivity multiplied by cross sectional area T out minus T in divided by thickness of the wall. So we will use this formula to calculate the heat loss. So Q equal to thermal conductivity is 1 into cross sectional area is 20 multiplied by T out minus T inside is 298 kelvins divided by thickness of the wall, which is 0.3. So we have Q equal to minus of 20 divided by 0.3 T outside plus 20 into 298 divided by 0.3. So if we simplify these terms, we get Q equal to 19,866.67 minus 66.67 times T out. So if we see this equation, we can see it is a equation of the line. So heat transfer is linear. Heat transfer here can be said as it is linear. So for now we have two more thermal conductivities, which is 0.75 watt per meter Kelvin and K3 equal to 1.25 watt per meter Kelvin. So if we use the Fourier's law for both of them, we can say for K2 we can get heat transfer equal to 14,900 minus 50 times T out, and for this K equal to 1.25 we can get 24,833.33 minus 83.33 T out. So we have equation 1, equation 2, equation 3 for the ranges of T out between minus 15 degrees Celsius to 38 degrees Celsius. If we plot these lines, we get some graph like this. So the orange line is for K equal to 1, the green line is for thermal conductivity equal to 0.75, and the blue line is for thermal conductivity equal to 1.25 watt per meter Kelvin. So from this graph we can observe that the heat rate is decreasing linearly for all three cases and it finally becomes zero at temperature equal to 25 degrees Celsius, at temperature equal to 25 degrees Celsius for all three cases. So what is happening here? So for temperature from minus 15 degrees Celsius to temperature equal to 25 degrees Celsius, the inside temperature is more than the outside temperature. So heat transfer is happening from inside to outside, and for temperatures between 25 degrees Celsius to 38 degrees Celsius, the heat transfer, the temperature outside is more than that is in more than inside. So heat transfer is happening from outside to inside. So this is the first observation. Then if we see the value of thermal conductivities, so from the graph we can conclude that if the thermal conductivity is more, then the heat rate or the heat transfer would be more. If thermal conductivity is less, then heat transfer will also be less. So these are the two conclusions we can draw from this chart. So that's it for today, guys. Thank you for watching. Bye bye.